during this sprint, we have, and during previous sprints, we have made efforts needed to deploy build variants, and we have actually gone very far and very close to finalizing this task. And it was a very interesting and challenging actually task, and I have now started to summarize. So this is basically the steps which are needed if you want to migrate your existing dependency chain to the generic dependency chain and build variants. So I have started to summarize the steps in a general form, the steps that are needed, and so I will now present you current results. So the goal for this migration and using the goal in using having this generic TCJS dependency chain and build variants is to limit the number of transformation configurations that are used in your projects, and to simplify addition or modification of target platforms. So this is how it should work when everything is in place. So you have one generic TC transformation configuration, and different target platforms, they are specified in build variants. So this one holds common settings, which are common for all platforms and which are specific for the project, and you apply different platforms on top of this TCJS using build variants, and you get a configuration suitable for building for a concrete platform. So now the problem in doing this step and achieving this goal is that usually there are quite many different TCs, and they contain specific settings for different platforms, and the steps that are needed should actually remove all these platform specific settings from the TCs and create one generic TC out of several. So during deployment of build variants, one of the important steps is to take the back the action should be to the left when you are doing this deployment. So you have on the right as an input, you have very many different TCs, and the goal is to remove platform specific parts and store only one transformation configuration with common parts. So now let's see what are the steps. So first important step is to convert to the new TC JavaScript format for the transformation configurations, because build variants can be used only with the new TC JavaScript format. And I would recommend to do this from command line. This can be done by a simple script like bash that just searches all TCs and calls model compiler from command line and converts to TCJS. This is an important and quite simple step, and it will generate all TCJS, all transformation configurations in the new format. This also can be done from user interface. So if you want to try it, there is a command in HCL RTist. But after you have tried it, I would recommend to create a script that will do this at once as one step. The concern may be the size of this TCJS, but I would mention that TCJS, this new JavaScript format, it is much more compact than the legacy XML format for transformation configurations. So I hope it will not be a big amount of or a big size on the disk if you convert everything at once. Next step is to list all known and supported target platforms. So before doing any conversion, you should analyze what are your legacy TCs and what is used, which target platforms are used, and which additional settings to the target platforms are used. And after you have migrated to TC JavaScript format, this is a textual format, and for some of the analysis, you can use simple tools that work with the text. So I would say that after you have migrated all your TCs to TCJS, the analysis of what is inside your TCs can be done in a more straightforward and simple way by just using grep, for example, or some other textual tools. Also, the same is if you want to compare, for example, to TC JavaScript, then it is also much easier with the new format. So one of the next step, number 2, is to identify naming conventions. So in order to automate this conversion, you need to understand what naming conventions are used for your TCs. First of all, you need to find which names are used for the files themselves. TCJS files for different target platforms. Usually this is some postfix or prefix identifying the platform. But in the very common case, you just there could be just very specific names, and you should list, you should search and list those. And create a mapping, so understand how the files are named, and create a mapping between file names and target platforms. So identify how you will detect target platform from the TCJS file name. Of course, this in very complex cases, maybe some additional scripts should be used, but according to our experience, analysis of file names is good enough, and actually not complex. Then also you need to identify the general name, because you don't want to keep this platform-specific name with the postfixes and prefixes, but you need to identify how will you extract the name that will be used for your generic. So like this, my project. It was, for example, it was my project _OC_Linux, and you need to extract this my project. So you need also to understand how the files are named, and what would be the best general name in your case. Also, naming conventions should be analyzed for these TCJS fields, which also can contain some general names and platform-specific postfixes or prefixes, like target project. Usually target project can have some basic name plus some underscore platform specific name, also target configuration name and unit name. So analysis of TCJS file plus these three fields inside TCJS will give you the best opportunity to select, to identify target platform in the very correct way, and to extract the general common name for your project in a correct way. So this is just a hint of which functions might be needed. So get target platform and get basic name. Next step is to identify platform-specific settings. So you need to talk to your experienced guys and list what are settings required for each target platform. This includes compile arguments, inclusion paths, link arguments. It is good to have maybe to search for some documents or documentation about this. So what settings are needed for each target platform? Sometimes there are different settings related to the optimization or to some additional debugging settings, and so you need to identify exactly which platform settings are needed. And also you need to list the properties in TCJS that contain these platform-specific settings. So this is the common places where platform-specific settings can be found inside your thesis. So as I mentioned, this is compile settings, link settings, make settings, and inclusion paths. But there could be more. For example, maybe some prerequisites sometimes can be different. So you need to find all properties in TCJS that can contain settings which are specific, which are not common, but which are specific for the platform. Because later you will need to extract those, to remove them from your thesis. I would like to mention that there are some properties that are fully platform specific, so they will be not added to your generic TCJS at all. These are fields like target configuration. This is target RTS. This field is always set by a build variant, so you shouldn't bother anymore about this for your common settings. Then compilation make type is also platform specific, and you don't need to set it anymore. So this will be done by a corresponding build variant. And also target project. Sometimes, maybe quite often, target project name is also you have different target projects for different platforms. That means that the name of the target project is platform specific, and it also should be set by a build variant. And now, after we have done all these analysis, we need to decide on the conversion scripts. Because manual analysis and manual generation and manual creation of generic TCJS is very slow and very error prone. So you definitely need to use some scripts. And at Ericsson, we were using the same approach with build variants. The same approach which is used for applying build variants. We use the same functionality to define conversion, and we just used this, did this during post-process step when your TC that you are loading, it is loaded and everything is initialized. Then in post-process, you have access to the TC and to all of the fields, and you can implement in these post-process functions all the steps needed for conversion. So analysis, comparison, and generation, creation of generic TCJS. So the benefits of this is that it is straightforward. So we already have everything for it. You just need to write it in JavaScript. Using the existing framework with build variants. Then it is also available, there is a user interface available, so you can add some options. And you have access to the logging functionality that will print information and errors and warning messages. So this is how this function looks like. So it takes the top TC as a parameter, and also all TCs as a parameter, and potentially some additional arguments, but probably you will not need them. So we were using this approach, and it actually proved to be quite good. JavaScript is very powerful and useful for this kind of analysis, because next step, so now we started to implement these conversion scripts, and we were implementing this analysis of existing TC settings and removing of platform-specific settings from the existing TC and keeping all other settings. So JavaScript was very convenient because very many sets and maps are used, and it is very convenient. One of the functions that are required to be implemented is this function. So get argument set it takes a setting for some field name, for example, inclusion paths. So it takes this setting. Of course, all of these functions should also take a TC, which is analyzed. I forgot about it as the first parameter, and then the name of the field, and it will return you a set of all arguments. So it will split if it is comma separated or space separated, depending on the field which you are analyzing. It will split and create a Java set. The next functionality that is needed is filter arguments. So it will filter, remove all platform-specific arguments from the set. And next functionality is merge arguments. This is needed for because you have several platforms. So you are not doing this analysis for only one platform dependency chain, but you are analyzing all available platforms at once. And for that case, you might have different, slightly different settings for different platforms, and you need to merge. So you need this merge functionality. So now I will talk about this a little in a little bit more details. So step 6, this is you need to handle platform variations. So you perform your analysis for all available platform TC JavaScript files. Wait, sorry. If we come back to this first slide, then you take all these 4 TCs and you try to extract one out of them. So at the same time, you are analyzing settings for 4 different platforms. Sorry, what did I do? So step number 6 is this analysis of all available platform TCs. So you should select one main platform from which you will take all settings, not only the ones that are platform specific, but there are fields which don't contain platform specific settings, and that fields you will take as defined for some your main platform. And during analysis we are loading other TCJS files for other platforms and doing this comparison and merging of the settings. So after removal of all platform specific settings, ideally for example for all 4 different platforms, you should have the same settings remaining for the common part, and it is very good if you do have it like this. For example, after you have removed all include paths which are specific for different target platforms, then out of 4 platforms you have received a list of inclusion paths, and all these 4 lists, they are the same, because only common settings specific for, not for the platform but for the current project, only those remain. But if not, what to do if not? Because we're not in an ideal world, and sometimes this does not happen. Then we are moving to step number 7. And we are storing, so you need to store. If still for your TCJS there are some platform-specific settings that were not removed by this filtering analysis, this means that you have some additional settings which are specific for these and concrete and these current TCJS and for some current platform. And in that case, we have found a good solution, and we have used it, and it proved to work quite well. Having additional field in the TC where we actually store. So if we have any special settings still left which are platform specific, then we store them in this section with platform specific settings. And so this is the name of the platform, colon, and here we define a map which is the name of the property for which we found specific things, and these special things, the definition of the special things. For example, optimization settings, for example, can be different and can be specific for a concrete TC and concrete platform. So you cannot move all your optimization settings to the build variant for the platform, but you need to keep it inside your TCJS. This is one of the examples, this 0, where you need to have it in your TCJS and not in the build variant. So this declarative approach, it is supported by our TCJS editor, and it does not break anything. So we have tested that it is quite well, working quite well. And after, so this is just the declaration, and this is handled. So this declaration is handled by a build variant when a concrete platform is selected for build. Then build variant will apply general things, and also will check if your TCJS has some target platform specific settings. Then it will also append them to the general ones. And the last, maybe not last, but one more step which is needed is implementation of good logging. So during this conversion by the scripts, you are actually doing quite many decisions, and we are finding inconsistencies, we are finding user mistakes in the TCs, and you need to implement very good logging. So in the future, you will just store this conversion log, and if there are any problems with the new created generic TCJS files, you just can check what was in the log, were there any warnings or errors during conversion. And we have this MSG.formatInfo, format warning, format error, predefined functions for logging. And if you are using this from HCL RTist, then you will see all this information in the console. Otherwise, in the command line, it will print it to the command line. So one of the hints is that we recommend to use converted from comments. So you are generating, creating a generic TCJS. You are analyzing several platform-specific TCJS. So we recommend to to store them in a comment, so you know which files were taken for this conversion and the first one will be the main from which you have started, and these three was additional TCJS also loaded for this analysis. And also optional, but maybe useful, is to save this list of platforms formally. So this comment converted from is informal. This is just a comment, but you can also save the list of platforms that you have found formally inside your TCJS. And like this, so create a field target platforms and just list all the platforms that were originally available for this TC. So maybe this information will be useful in the future. And in any case, this is just one line. So if this is in the future, if you will consider this as useless or not important anymore, you just can by a simple script just remove this line from all your TCJS. So textual format is very good for different scripting things. That is basically it, all of the steps. And next thing that maybe would be good for us to consider is to prepare a framework with helpful functions for conversion. So so it will be available not for a concrete customer, but this framework will be available somewhere global for all customers in RCRT. So might be useful. This is for us to consider for the future, because I have already listed several functions which can be useful for all customers which are going to do this conversion. So that's all. Do you have any questions?